Let's determine whether the following function is continuous at a point. Here we have the function f of x is equal to 2 minus x if x is less than or equal to 2, and then also x squared minus 2x if x is greater than 0. In order to determine continuity, our first step is to evaluate the function at a, and at this point we want to look at a being equal to 2. Now, if we evaluate our function, this is less than or equal to 2, so we're going to plug that in to the first function, 2 minus 2, which gives us a value of 0. So the first requirement is attained here. We can say that the function does exist at 2. Now we need to determine whether or not the limit of this function exists at 2. And for a piecewise defined function like this, what we'll do is we'll look at the left hand and the right hand limit. First, the left hand, the limit as x approaches 2 from the left of our function. Now, because the x values we're plugging in are less than 2, we're going to use our first function, 2 minus x. And as we get closer and closer, we see that that is equal to 0, again, just by plugging in a 2. Now we'll look at the limit as x approaches 2 from the right, or a right-handed limit, and because our values are greater than 2, we're going to use the function x squared minus 2x. And when we evaluate, we have 2 squared minus 2 times 2, 4 minus 4, so this is equal to 0. Since the left hand and the right hand limit agree, we can say that the limit as x approaches 2 of this function does in fact equal 0. Now, the third requirement for continuity at a point is that not only does the limit have to exist at that point, but our limit value has to agree. And so since our limit attains a value of 0, we can say that this function is continuous at the following point at a equals 2. So this is an example of a function that's continuous at a point.